My name is Sosale Mohana. I have taught A-level maths for a long time, and I'm going over some of the topics to help students like you revise. And the last time I taught you how we recognize the format for an equation of the type aCosx+b. In fact, it's actually a transformation. Look, for example, cos of x minus alpha would mean you move the graph to the right by alpha and then stretch it. Remember way back f of x plus a and then a f of x. Remember the transformations I taught you? Is basically these are transformations of sine and cos. But we don't have to worry about it. And I also went through this. You see, remember I said r equal to root of a squared plus b squared and tan alpha equal to b over a. I showed you how we get those. So let me take some examples. So as usual, you see, new formula, equations, identities. Fortunately, no identities, equations, and then, of course, there are identities, but they're straightforward. Equations and then maximum, minimum, the graph of sine and cos. We're coming to that in a minute. Sorry, in a couple of lessons. So now I'm going to solving equations. I'll take a couple of examples. Let me take the first example. Solve 5 sin x minus 12 cos x equal to 12 for the range 0 less than or equal to x less than 360. A question like this will not come in this format in the exam. In the exam, the question would be 5 sin x, express 5 sin x minus 12 cos x in the form r sin x minus alpha, where r is greater than 0, 0 less than alpha less than 90, or alpha is acute, and hence solve. That's what they ask. So therefore, first I'll write this as 5 sin x minus 12 cos x. Remember, sine first is a sine function, it's a minus, so it is x minus alpha equal to r sin x minus alpha. My job is to find what is r, what is alpha. So let's expand this. I'll write below here. So r sin x sin alpha minus r cos x cos alpha. So these two must be the same. These two must be the same. Remember, the minus signs match. So sin x can be cancelled. So r sin, oops, what is wrong with me? Cos alpha, idiot. Sin alpha. Shoo, that was a blunder, wasn't it? Okay. R sin alpha, r, when you compare, okay, let's write down and do it. Why confuse you? So 5 sin x equal to r sin x cos alpha. So I can cancel sin x. I can say cos alpha equal to 5 over r. Some teachers use r cos alpha equal to 5. Okay. Similarly, 12 cos x. Oh, I will use here cos alpha equal to 5 over r. Okay. Some teachers use it in a different way, so let's do that as well. 12 cos x equal to r cos x sin alpha. Cos x and cos x cancels. So r sin alpha equal to 12. I will use sin alpha equals 12 over r. Be careful, the negative sign is absorbed because they are identical. If you have a negative, unless the question has been given the other way around, which is rare, you should not have any negatives here. Okay? Right. The way some teachers would do will be square and add. r squared cos squared alpha plus r squared sin squared alpha is 5 squared plus 12 squared. So r is 13. Perfectly correct. Divide r sin alpha by r cos alpha. I get tan alpha equal to 12 over 5. That way is alright. But I prefer this because I don't want to commit errors. As it is, I committed a blunder today. That is alpha. Sin is opposite over hypotenuse. Cos is adjacent over hypotenuse. So what is your r? R is root of 12 squared plus 5 squared, which is 13. Tan alpha is 12 over 5. Okay, let's find the answer for 12 over 5. Shift, oh no, shift tan 12 divided by 5. 67.4. I should remember that answer. So I could write this as r is 13 sine x minus 67.4. Yeah, but this is how you do it. There's nothing wrong. Compare coefficients and find out. But do you see that formula which I have written? As long as you are convinced that this expression is correct, your a is 5, your b is 12, r is 5 squared plus 12 squared under root. You get 13. Tan alpha is 12 over 5. You get 67.4. You can do it directly. From next question, I'll do it directly. So therefore, now I am solving 13 sine x minus 67.4 equals 12. So sine of x minus 67.4 is 12 over 13. Now this is where I purposely took that value. Shift sine bracket, oh there are two brackets, 12 divided by 13 close bracket, 67.4. Very interesting. PVs, don't bother, sir, I got 67.4. You think I'm wrong? No, just go ahead. It's perfectly alright. So x minus 67.4 equals, sorry, SV is 180 minus 67.4. 180 minus 67 is 113, 112.6 is equal to 360n plus 67.4, comma 360n plus 112.6. So x equal to 360n plus 2 4s are 8, 2 7s are 14, 1, 2 6 13, 134.8, then 360n plus 112 plus 60, 179, 180. Put n as 0, I get 134.8, 180. Put n as 1, crosses. Put n as minus 1, below. So you have your two answers. Right? That's okay. Let me take another example. I have some time. I want to do two more examples. I have done, okay. Example 2. Find the values of r greater than 0 and alpha 0 less than alpha less than 90 for which 3 cos x, 3 cos 2x, no, 3 cos x is fine, 3 cos x plus 4 sin x equals capital R cos x minus alpha. Hence, solve. 3 cos 2x minus 20 plus 4 sin 2x minus 20 equal to 1. For values of x in the range minus 180 less than x less than 180. That's the question. I'll just work this out and then show you. Okay. The first job you do is you're being given this. So that's a plus. When I expand cos of x minus alpha, it's going to be a plus. So the signs match. Don't write anything else. You can just say r equal to, this is your a, that's your b, r is root of a squared plus b squared, which is 5, and alpha equal to tan inverse b over a. B is 4 over 3, which is 53.1 degrees. You straight away can write that, because r is root of a squared plus b squared, tan alpha is b over a. But if you don't like it, you are welcome to expand, compare coefficients, draw the triangle, and come to the same answer. No problem. So therefore, now I know that answer. R is 5. Okay. Now let me write this question. 3 cos x plus 4 sin x equal to 5 cos x minus 53.1. Yeah. But now you're asked to solve 3 cos x minus 20 plus 4 sin x minus 20 is equal to 1. Now, the only difference you can see is in place of x I have x minus 20. Otherwise, I could apply that formula. So I can straight away say 5 cos x minus 20 minus 53.1 equals 1. You understand that? It doesn't matter what you have here. I think it was 2x. Okay. 2x. 2x minus 20. In other words, x is replaced by 2x minus 20. That's all. Otherwise, the format, the signs, the functions are all the same. So therefore, I can now rewrite this as, don't worry, you'll get this in the handout anyway. Cos of 2x minus 73.1 equals 1 over 5. What's your PV? Cos inverse 0.2. Shift cos 0.2. 78.5. So 2x minus 73.1 is 360n plus 78.5, 360n minus 78.5. So 2x equal to 360n plus 78, 148, 151.6, or 360n minus 78 plus 73 is 5. 5.5 minus 0.1 is 5.4. So x equal to 180n plus 3 7s are 14, 3 2 7s are 14, 111, 2 5s are 10, 8, and then 180n minus 2.7. Then put n as 0, 75.8, and that's out. No, I said minus 180 to 180, isn't it? Oh yeah, I can take that. Minus 2.7, and then put n as minus 1, that is out. Oh, sorry, minus 180 plus 75 is minus 105, so minus 104.2, accepted, that's out. Put n as 2, I'm sorry, n as 1, that's out. 180 minus 2, 178.3. So you've got 4 answers. It's 2x, so you expect 4 answers. Get it? Ultimately, it comes down to solving a trig equation, the 3 formulae which I have taught you. I'll just write one examination type of question, and I will add something toward the end which I will take up in the next lesson. Example 3. Express. Let's take a decent example. 12 and 5 and 13. Okay, I did that. I've done 15 and 8 and 17. Okay. 15 sin x plus 8 cos x in the form r sin x plus alpha. I don't want to write where r is greater than 0, 0 less than alpha less than 90. Hence, part A. Solve 15 sin x plus 8 cos x equal to 5. Part B. Find the greatest and least values of 15 sin x plus 8 cos x equal to y, giving the smallest positive angle x, where these occur. That would be a typical 10-12 mark question in the exam. As I said, I'll do the first bit. So look, this and this formats agree. So that's your A, that's your B. So R equal to root of 15 squared plus 8 squared, which is 17. Tan alpha equal to B over A, which is 8 over 15. So your alpha is, what's tan inverse 8 over 15? Shift tan, open bracket, 8 divided by 15, close bracket, equal to 28.1. Okay. So having got that, so now I have expressed this in the form. So you write this as 17 sin x plus 28.1. Okay. So I'll just rub this off. So I can write the question as 17 sin x plus 28.1 equal to 5. So sine of x plus 28.1 equal to 5 over 17. What's your PV? Sine inverse 5 over 17, shift sine bracket 5 divided by, oh no, shift, first let me do that, the other one was it correct? It was what? 8 and 5, shift tan 8 divided by 5. Oh, 15, 8 divided by 15. Yeah, that was correct. So this is shift sine bracket 5 divided by 17 is 17.10, so 17.1. SV equal to 162.9. So x plus 28.1 equal to 360n plus 17.1, 360n plus 162.9. So x equal to 360n minus 11, 360n, 9 minus 1 is 8, 162 minus 142, 134. Then you can put n as 0, 1, 2, 3 and get the answers. So that is easy. That's the first part, which I will rub off. I want to leave this question here. Alright. The only thing I will write here is 15 sin x plus 8 cos x equal to 17 sine x minus 28.1. I'll leave it there, OX plus. I want to stop at that stage. I will answer part B in the next lesson. Okay? Bye-bye. Hello. I want to take this opportunity to propose a vote of thanks. I would like to thank Vivid Innovations Private Limited and Commerce Forum for so generously giving up their studio and the facilities and the services of their technicians to record all these videos for free. I think that needs to be acknowledged and appreciated. Thank you very much. And my special thanks to Mr. Nitin Mahadevappa, Mr. Nishant Guruswamy, and Mr. Sadan Kumar DN for all their help and assistance in getting these videos ready, uploaded, and launched. Thank you very much.